Dear student, welcome back. And here we are going to look at what happens, the different phenomena that takes place when light interacts with the material. We know different materials are made of uh, atoms and molecules, and each material has got different bonds, has got different structures, meaning chemical structures and chemical composition. And because of these differences, different materials interact differently when exposed to light or affects light differently. So like the first phenomena that is very common is reflection. Reflection happens when you have incident ray going through the surface of the material and it's reflected back. So usually the surfaces or materials which actually exhibit this property are materials which are usually smooth in terms of nature of the surface. So when light comes back from the direction from which it was transmitted, or it emerged from, that is a reflection, as you can see here. But sometimes we have a scenario where light slightly bends and then emerges on the other side. So the bending is refraction. This is incident ray, it refracts a little bit here, and then it's transmitted, it gets outside on the other end of the material. So that is transmission of light. In other cases, light is trapped within the material and it doesn't get outside. This we call absorption. So when a lot of light is actually trapped within the material, we say this material is highly absorbing. Sometimes light, goes to a direction which is not transmission, not absorption, and not reflection. It can be kind of forward scattering or back scattering, but scattering is like light actually is kind of spread and lost somewhere, not within the material. Of course, sometimes that might happen, but it's different from absorption, reflection, and transmission. So scattering also is one property that can happen depending on the nature of the material and how this material scatters light that is shined onto it. Yeah, so we'll continue, and on the next part we're going to concentrate only on transmission side of things. To make things simple, we are going to ignore all the other types of phenomena that happen when light interacts with matter, and we are going to only consider a case where we have transmission of light. So if you have incident ray coming in with intensity IO, and then it goes through the material, emerges on the other side with intensity I. As you can see, the arrow with intensity IO is bigger, meaning that the light that is incident is actually larger, but then the light that gets out of the material is smaller. As you can see, the I that we have in the arrow is smaller arrow. So usually we expect in many materials that the light that goes through, some might be a little bit reflected, some might be lost within the material, and then you usually have intensity at the output is usually smaller compared to the intensity at the input. And then when we talk about transmission or transmittance, which is the one property that we use, is like transmittance is the ratio between you take I divide by I naught, or I divide by IO. What does it mean? The intensity that we get, the transmitted intensity, divide by the incident intensity, we get the transmittance. So transmitted intensity divided by incident intensity, we get transmittance. And when we do different kinds of measurements, we could use this principle to actually characterize some few, let's say, or some simple samples like water, like liquids like coffee, and this is what we're going to explore further in the coming episodes. Hello. So we consider transmission of light because, as you can see in our setup, we're going to deal with light that is transmitted. We're going to ignore all the other interactions that happen when light interacts with the material. And our light here is basically this LED here. It's giving out white light. And this is our sample space. So this is where material is going to be. At some point, we will measure the compartment itself, meaning we'll measure the sample holder itself. And then on the other side, we have a photodetector. So this is the sensor which detects light. So is like light that is transmitted is what we're going to take care of. Light that's emerged from this side goes through the sample and is received on the other side. So that is transmission. It is the principle that we're going to use. That's why we have actually ignored all the others. So we start simple, and then as you go further with your further studies, you'll be able to study other complex scenarios. Thank you for listening.